go through the extra examples that I've provided in the worksheet that you might have found attached to this document, this lecture document. So if you pull that out, you're going to see we're going to look at the market for University of South Carolina football tickets, and we're going to assume a normal supply and demand curve, not worrying about elasticity. That's important because we know that the supply of football tickets is very inelastic. There's only so many seats available, and so we don't see the seller as easily changing the amount that's bought and sold in the market. However, again, we're going to assume that we have a normal supply and demand curve, and what we mean by that is I'm just going to draw in these generic supply and demand curves, and then we're going to look at, in each of the different cases, how does the market change. All right, so for our first example, what we see is suppose the university expanded the stadium, increasing the number of seats the stadium could hold. So what does that mean? All right, so first off, we want to think about, does this affect the buyers or the sellers in the market? And we're going to see that who cares about the number of seats that are available? That's the suppliers. As a result, there may be more buyers who can purchase tickets, but the first thing that happens is that the university can supply more tickets, and the supply then has increased. So supply has gone up. So what does it mean when supply increases? And again, it's always easy to say, oh, supply goes up and let's point this up. No, that's not correct. What it means is instead that supply has increased at all price levels. And so we can draw in our new supply curve, and let's call this S2 here. And we can compare our S2 to our old equilibrium price. So I'm going to call this P1. Initially we were at P1, and now we're at P2. And P2, as the supply increases, the price has decreased. We're now at a lower equilibrium price. Our equilibrium quantity used to be at Q1, and it has increased to Q2. So as a result of the expansion of the stadium, we see that supply has increased, prices have decreased, and the quantity bought and sold in the market has increased. All right, so how might I ask this question on a test or quiz? Well, first off, I could show you a picture of a bunch of different graphs, some of which one of which would have the supply curve shifting to the right, and that would be the correct answer. I could have the supply curve also shifting to the left and say, okay, what if S2 was over here? And that would be incorrect, right? S2 didn't shift to the left. There was an increase, not a decrease at all price levels. So a supply curve shifting to the right could be one way of answering this question. The next would be to look at what happened to equilibrium. The equilibrium price went down, the equilibrium quantity went up. That could be another type of question I could have asked. And so think about and do this whole process of drawing out the graph to really see what happens, because it's easy to make a mistake and say, oh, I think prices are increasing and quantities increasing when I increase my supply curve. Well, make sure you go through that example, because you would have noticed that that was wrong after you analyze your old equilibrium compared to your new one. All right, let's move on to the next example. ABC is covering all of the University of South Carolina's games on local television. Well, so yes, the university might care about this. Yes, they might think it's really great, but it doesn't really affect the supply of seats available. What it does affect is people's demand. If I can easily watch the game on my TV and not have to pay to go to a bar to watch it, or not have to pay for an extra channel or anything like that, if I can easily find it, this is going to be a substitute product. And it's a very inexpensive product. And so the demanders are going to be the ones that care about this, and demand is going to decrease if it's easier to watch the game in other ways. And so as demand decreases, we're going to want to look at what does that mean for the shift. And again, it means that at all price levels, we're going to decrease our demand. So at high prices, at low prices, in every case, we're going to decrease our demand, and we can compare our old equilibrium to our new equilibrium. Our old equilibrium had a price of P1, our new equilibrium has a price of P2. Price has decreased in this market. What about quantity bought and sold? Our old equilibrium, we saw we had a quantity of Q1. Our new equilibrium is Q2. Not only has price decreased, but quantity has as well. And so in this market, we saw a decrease in demand or a leftward shift in the demand curve. Both the equilibrium price and the equilibrium quantity fell as a result. All right, and question number 3, a fire destroys half of the seats in the stadium. We are all devastated. As buyers of this, we are all devastated. But first, the university has to supply fewer tickets at all price levels. There's not as many tickets available, and so supply has decreased at all price levels. We can then compare our equilibrium, our old equilibrium, to our new equilibrium. And let me just write supply decrease. And again, it looks like an increase, right? People tell me that that looks like an increase, but we're saying it decreased in quantity. It decreased in quantity at all price levels. All right, comparing our old price P1 to our new price of P2, the fire caused the price of tickets to increase. And as a result of that price increase, oops, I went the wrong way there. As a result, we can compare our old equilibrium of Q1 to our new equilibrium of Q2, and the quantity bought and sold in the market has decreased. All right, so supply decreased, it shifted to the left, and we see as a result, the price has gone up. Their price of each ticket is now more expensive, and the quantity bought and sold in the market decreases. And right, that makes sense because there's a fire and a bunch of the seats were destroyed. There's not as much product available. So as a result, we see the quantity decrease. It's more scarce. The price goes up. All right, what about unusually cold weather? Unseasonably cold weather hit South Carolina. Game time temps are in the 20s. I don't know about you, but that is really cold. That doesn't affect anything with the supply, right? The university still has the same number of seats available, but who cares about that? I care about that. I don't want to sit out and watch a game in the freezing cold. I'm going to watch it on my ABC channel, right? And so what we see again is a decrease in demand. The quantity demanded decreases at all price levels. We see that shift to the left. All right, and as a result, we can compare our old equilibrium price to our new equilibrium price. So P1 compared to P2, our equilibrium price has gone down, and our quantity has also gone down. There are fewer buyers in the market who are willing to sit out in that cold weather, and so the quantity bought and sold in the market has also decreased. All right, in our next one, the University of South Carolina enrollment hits an all-time high, bringing in many students from outside the state. And it might be that they started out not a Gamecock fan, but in the end they become a Gamecock fan. And so what we see here, larger number of buyers, more people who are entering into the market that want to purchase this product. And this is going to cause demand to increase. The university didn't build a bigger stadium or anything like that. But what did happen are there are more students on campus, and the more students mean a greater number of buyers. Remember, number of buyers plays a big role in determining where a demand curve falls. And since there's more buyers, there's more competition for those tickets, and as a result, the equilibrium price is going to increase. So demand increased, and it shifted right, and that as a result drove up prices. And what happened to quantity? Our equilibrium quantity initially was at Q1. Our new quantity, when we look at our demand curve 2, is at a higher quantity, so price and quantity both increased as a result of an increase in the number of buyers coming into the market. All right, next. University of South Carolina is having a great year. All fans are very excited about the prospects of a great year of games. All right, so in this case, now we're talking about preferences. All of a sudden, there's more fans, new fans. Everybody's really excited. I don't want to just watch a great game on TV. I'd rather see it in person, and demand is going to increase. And it increases at all price levels, and that shifts that demand curve to the right, a rightward shift in the demand curve. We can compare our old equilibrium of P1 to our new equilibrium. The university can now charge a higher price for those seats, and more people are going to go, even though it's a higher price, because they are so good that we want to watch good football. All right, so price and quantity both increase as a result of preferences moving towards watching the game in person. All right, so now we're going to get into some price control. So a price ceiling of $10 is put in place. All right, and so I'm going to guess that most of us pay more than $10 for a seat. And so let's say that our price ceiling is down here. And a price ceiling, remember, ceiling is the maximum place in the room. So the government, the state wants to make tickets more affordable, and so they're saying the maximum price is $10. Any price above $10 is illegal. And our equilibrium price, depending on what kind of seats you have, it could be maybe a $50 seat. Well, the university used to charge $50, but that's illegal. You can no longer charge $50. Instead, you can charge $10. Well, I wasn't willing to go to a game for $50, but at $10, I'll definitely go to a game. The law of demand tells us as the price decreases, which is the case for a binding price ceiling, we're going to see an increase in the quantity demanded. And so the quantity demanded has gone up. At $10, the university is less willing to supply seats, and so the quantity they supply goes down, and we can see the difference between the quantity supplied and the quantity demanded. There's QD people in line to buy the product, but only QS seats for sale. And so we're going to see that we're short. We're short QD minus QS. And so in this example, we have a binding price ceiling, and it's going to result in a shortage of the quantity demanded minus the quantity supplied. If instead the university said, we have a price floor, the minimum price you can charge is $10. The university was already charging $50, so they're not charging less than $10 for a seat. And if we would have set a price floor, that would have been a case where we had a not binding price floor. Remember, a price ceiling is binding when it's set below equilibrium. And a price floor is only binding when it's set above equilibrium. All right, so if it would have instead been a price floor of $10, it would have not been binding. But since it was a price ceiling, the government came in and set the maximum price to $10. The $50 price that was being charged was illegal, and it resulted in a shortage of QD minus QS. All right, now let's look at a tax. So suppose the state government instead decided to raise revenue by imposing a $10 tax on each ticket sold. All right, so when we impose a tax, and again, we're just kind of putting in some generals here because we don't have actual numbers, but we're in our equilibrium. We know that a tax means that it's going to say your ticket cost plus the tax of $10, and then you have your total. And the total is the price buyers pay, which has to be $10 more than the price sellers receive. And that's going to happen when we move to the left of our supply curve. And we can draw in a tax wedge. And let's assume that this tax wedge here is a $10 tax wedge. So I went through and I determined where my $10 fell. And now where I hit the demand curve is the price buyers pay. Where I hit the supply curve is the price sellers receive. So buyers pay